Good morning, students. You are all welcome to further math class today. In today's class, we still want to continue with what we started in trig identity or trigonometry. So we could recall from last class that the trig identities are sine, cosine, tangent. And you can also remember that we said cosecant or cosec is 1 over sine. Then secant or sec is 1 over cosine. And then cotangent or cot is 1 over tangent. So what we'll be doing now is to bring out the trig identity. So we want to look at trig identities. Alright. Remember from last class, we were able to identify some things. We said that since this is the positive x-axis, so we can say this is x. This is positive y-axis, you can say this is y. And then our hypotenuse is a unit, so you can say it is 1. Then, referring to SOHCAHTOA, we said that sine, okay, let's put an angle here, theta. So we can say sine theta is opposite over hypotenuse. And opposite here is what? Y over 1, and that's y. So sine theta we can say is y. Then cos theta adjacent over hypotenuse. Adjacent here is x over 1, and that is x. So this is what we'll be using. And then from our knowledge of Pythagoras theorem, we know that the sum of the squares of the two sides is equal to the square of the hypotenuse. So we say y squared plus x squared equals to 1 squared. And what is y here? Y is what? Sine theta. So you say represent it with sine theta square plus what's x here? Cos theta. So cos square, and 1 square we know is what? 1. So in terms of trig, we can put the square in between. So this is sine square theta plus cos square theta. Okay, there should be a theta here equals to 1. So this is our first identity. Now if you choose to make sine square theta the subject of the formula, sine square theta, that means you are taking cos square theta to the right hand side. There is 1. So this will become minus cos squared theta. Again, if you choose to make cos squared theta the subject, it means you are taking sine squared theta to this side. That will be 1 minus sine squared theta. Now the next thing, we want to divide this first identity, sine squared theta plus cos squared theta equals to 1. We want to divide through by cos squared theta. To achieve that, we have sine squared theta dividing each cos squared theta plus cos squared theta divided by cos squared theta, and then 1 divided by cos squared theta. From here, we could recall that tangent is what? I believe you can remember. Tan is sine over cos. So this is square, does not change anything. It will just be tan square theta plus cos square theta divided by cos square theta will give us what? 1. Again, we know that cosec is 1 over sine and sec is 1 over cos. And what do we have here? Cos theta. So this is sine is sec is 1 over cosine. So since this is 1 over cos square theta, you just write the square. So this is sec square theta. So this is our second identity. So still using this first identity, let's divide by sine square theta. Still doing the same thing. Sine square theta divided by sine square theta plus cos square theta divided by sine square theta, 1 divided by sine square theta. Sine square theta divided by sine square theta is 1 plus cos square theta divided by sine square theta. We already know that tan is what? sine square theta divided by cos square theta. And we said from this place that cot is 1 over tangent, that's the inverse. So the inverse means sine is now the one down and cos is now the one up. So that's referred to as cotangent. So we say this is cot square theta. Again, 1 over sine square theta. Since cosec is 1 over sine, so we replace this with cosec square theta. So this is the third identity. So let's look at examples. Alright, the first example. Given that sine A equals 8 over 17 and tan A is an obtuse angle, find without using tables cos A and tan A. Now I want to consider the first identity we derived here. Sine square theta plus cos square theta equals to 1. But in this our question, the angle is A. So what you just do is to replace. You have sine square theta plus cos square theta equals to 1. So you just change it to A cos square A equals to 1. And then we have our sine A to be 8 over 17. Sine square A will just be the square of that. So that will be 8 over 17 all square plus, we don't know this, equals to 1. So the next thing is to take all of this to that side. Cos square A equals to 1 minus 8 over 17 square. So your cos square A equals to 1 minus 8 square is what? 64. 17 square is 289. So cos square A, we find the LCM here. LCM of 1 and 289 will be what? 289. So this 289 minus 64. And that will give us 225 over 289. Now, since your cos square A is 225 over 289, what we are looking for is actually cos A and not cos square A. So what you do is just to find the square root. So cos A will be the square root of 225 over 289. And we know that when we are finding the square root of a number, it's usually plus or minus. So your cos A is plus or minus. Square root of 225 is what? Is 15. Square root of 289 is 17. So you have plus or minus 15 over 17. Now I want to decide whether our final answer will be positive 15 over 17 or negative. Let's go back to the question. It is said that A is an obtuse angle. When we say obtuse angle, what comes to your mind? This angle is greater than 90, but what? Less than 180. That brings you back to your quadrants. If I'm to draw your quadrants, you notice that this is 0, 90, 180. So that angle will be at this position. And we know that from, remember this, add sugar to coffee, that sine is the only one positive at this second quadrant. So it means your final answer for your cos A will be minus 15 over 17 because cos is negative here. Now next one is to find tan A. We already know that tan A is sine A over cos A. So that makes our work easy. Sine A is what from the question? 8 over 17. So this over is division. Cos A is what? Minus 15 over 17. And we know to find the reciprocal, this will become times, and 17 will be the one up. So 8 over 17 times 17 over 15. Remember, there's still minus there. So 17 in 17 is 1. So you have minus 8 over 15. So that means your tan A is minus 8 over 15. Let's look at another example. Alright, let's look at these two examples. The first one is 1 plus tan square x. That is 1 minus sine square x. We have to show that this will give us 1. When you have to show something, what you just do is to solve the left hand side or the right hand side, depending on what you want to do. But since it's already equal to 1, we are not solving anything here. So let's look at the left hand side. Left hand side is 1 plus tan squared x, 1 minus sine squared x. Remember I told you that the angle here doesn't matter, it can be alphabet, it can be theta. Then let's go back to what we just derived. I believe you can see the 3 identities. Can we see something that relates to tan here? Tan squared theta plus 1 is sec squared theta. That's the first one. Then the other one, you can see 1 minus sine squared theta is equals to cos squared theta. So what we are just doing is just to replace. Remember, the angle does not matter, so you just replace it with x. So since tan squared theta plus 1 is sec squared theta, so you just come here, 1 plus tan squared x will be what? Sec squared x. That's the first one. The second one, 1 minus sine squared x, you can see it here is equal to what? Cos squared theta. So you just replace it. Since it's not x, cos squared x. That's that. Then the next thing, can we relate these two? What is sec here? 1 over cosine. So this will be 1 over cos. Now it's square x. Bracket is multiplication, cos square x. So let's divide. Cos square x divided by cos square x will give us 1. Hence, since your left hand side is equal to right hand side, that is the proof for that. Let's look at number 3. Alright, number 3, we want to simplify 1 over 1 minus cos theta plus 1 over 1 plus cos theta. In this case, because we have fraction, what you do is just to find the LCM. And to find the LCM of a number, you check the denominator, you just multiply them. So you have 1 minus cos theta minus 1 plus cos theta. 1 minus cos theta in this, that means this takes care of all of these. What are you left with? 1 plus cos theta times 1, that will still give you 1 plus cos theta. Then this taking care of this part, this is left. This times 1 minus cos theta. What do you notice? You can see cos theta and minus cos theta. So let's bring it out. This is what 2 plus cos theta minus cos theta. Then this, just for us to multiply. Remember, I taught you a shortcut in doing this, that you square the first, then you minus, you square the second. So let's do it. This is 1 square minus cos that square theta. So this take care of this because this is minus. Then this 2 over 1 minus cos square theta, because we know that 1 square is 1. Then from our identity, what can you relate to this? Here, this is sine squared theta. So this is equal to 2 over sine squared theta. Again, what can you relate to sine square or sine? Coming to here, you have cosec, that's 1 over sine. So since this is 2 times 1 over sine squared theta, so this part would be 2 times, relating it to that, cos. Now because there is a square theta, so that will be 2 cos square theta, cosec square theta. So that's that for this example. In the book, I'm giving you class 1. Thank you.